All right. On to MCP at the helm of autonomous. I'm going to be talking to you today about how you can sorry, leverage AI agents without blowing up compute and trust in your data pipelines. First, a little bit about me. I'm Josh, and I am a founding engineer working at Snowplow since 2014. And mainly, the mic, sorry. Hello? Mainly, I've been working across multi-cloud architectures and how to run data pipelines across AWS, GCP, Azure at really large scale. A little bit about Snowplow. We're a customer data infrastructure system, and primarily what you'd use Snowplow for is capturing customer behavioral data. So from all of your digital assets, you want to understand how your customers use your products, leverage your products, you can use Snowplow for that. AI-powered development is a really interesting thing that I'm assuming most people in this room have either been working with or know hopefully quite a lot about. And it's changing the rate of change. Oh, sorry. It's accelerating the rate of change at an unprecedented level. What used to take sprints or quarters now can take days or weeks to implement and get something running, get something live. And there's a huge temptation that comes with that to ship really quickly, really eagerly. And every exec team I've ever talked to, including the one that I work for, is pushing the same thing. Use AI, move faster, break things, go faster, go faster, go faster. And data is no exception to that rule. We know that data is an incredibly important asset that you have to develop, that you have to own to have a competitive advantage. So now we have AI. We should do that a lot faster, right? So let's take a very contrived example here of kind of you've been tasked with developing some tracking and you've got AI, so let's go and do that. So we want to create a data structure for tracking views to a product page, right? Again, very contrived example. So I had a bit of an experiment here. I said, right, Claude code, give me an example. And it did a decent job. Right, I have my product ID, product name category. It's added some extras. I don't know why, I didn't ask it to, but it's added some extras. I then went to Claude Desktop, and slightly different, right? Different casing, a lot of extras. I then went to Gemini, and again, it's giving me lots of different answers. So if you're leveraging LLMs or AI agents to go and figure this thing out for you, it's going to give you lots of different results. And even within the same session of Gemini, I said, well, I've got my web tracking now. I'll do it for iOS. And for some reason, it's stripped off product from all of my columns. When I go and talk to Gemini about this, I said, well, wouldn't it make sense if the columns were consistent? And after about 5 or 6 prompts, it finally said I was absolutely right, which we all know we are always absolutely right. It would be better if the columns were consistent, would make life a lot easier downstream, right? Data is going to be something you're collecting from lots of different places. If it's not consistent, you're going to struggle to analyze, you're going to struggle to use it, and you're going to have a lot of very expensive data sitting somewhere that you can't easily leverage. So there's a bit of a risk landscape here. If you've got kind of this uncontrolled change, you've got a bit of chaos. You've got lots of schema drift. You have lots of extra compute costs trying to rationalize different data, especially if you're using a schema on read system versus a schema on write system. You're going to be having to figure out how to coalesce this data, how to join this data downstream. So do we really want that? Well, probably not if we care about actually using the data for anything practical or real. And your trust in that data starts to erode. If data is an asset at your company and people don't trust it, they're not going to use it. You're not going to be able to build business use cases on top of data that doesn't have high trust. So let's take a second and think about an architecture that can maybe solve for this problem. So we need to use AI agents with context of the ecosystem they're contributing to. And that's really important. AI agents work best with context. They need a ton of context. We need to centralize maybe our schema registry. Right? We need a schema registry. Hopefully everyone in data is using a schema registry at this point. If you're not, you should be. And we need to start looking at a schema on write system. How do we shift data quality left? How do we ensure that what you're producing is accurate, is valid? We can't be fixing anything post hoc in warehouse anymore. And we need deterministic tooling to then implement that tracking, right? We can't ask an LLM to have any sort of guarantee on determinism. We know it's not deterministic. It's not designed to be deterministic. So if you care about quality, you've got distributed teams, you've got distributed products, you've got lots of different web assets, digital assets. You need some way to deterministically say, track this thing in this form, produce the right columns, produce the correct data. Otherwise, you're not going to have any sort of guarantees on data quality and very little trust in that system. A little bit on MCP here, right? So obviously that was in the talk title, so I do have to talk about MCP. And Model Context Protocol is a kind of a standard developed by Anthropic to give, again, AI agents that context that they desperately need to function correctly. And it lets you hook in all of the information you need to let the LLM work properly. So when we're thinking about data here, we need to feed it all of our existing data structures, all our existing schemas, as much detail as possible about how our tracking ecosystem actually functions today. That's an incredibly important part of building out a system correctly. You don't want it to hallucinate a new data structure. You want it to check, does it already have this? Have I already defined this? Has the team already developed this? Can I reuse this? Right? Or do I have any standards on how I'm tracking things, how I'm understanding my data currently? Leverage that. MCP is the hook to make AI agents work in that matter. So I'm going to talk about the Snowplow toolchain. It's the toolchain I understand best as I work at Snowplow and have done for a long time. At Snowplow, we have a CLI tool, which now has an MCP server for exactly what I was just talking about, right? We want to hook in MCP. We want to hook in AI agents to everything that we've already generated, our entire schema industry, all of our data structures, all of our definitions. We have a tool called Snowtype, which does our code gen, right? So when we're talking about implementing tracking in a website, in an app, in any server-side system, we're going to generate that tracking. And we're not going to leave it to someone's interpretation. We're going to generate the tracking from that schema that we've generated. Our pipeline then validates everything that's going through that system. So our clickstream data isn't just, okay, fine, we've produced something. No, we're going to validate it as well in stream and ensure that only quality validated data is going to make it any further downstream. And anything that's landing in a warehouse, in your data lake, in your iceberg tables, your delta tables, that's going to have schema on write semantics. So we're going to interpret, again, from the same registry, the same source, how should that data be defined? How should it be stored? So what does my setup tend to look like at Snowplow? Obviously, an engineer drew this graph. Sorry, it's poorly styled. Ultimately, I'm using AI and MCP for the ideation phase. And I think that's the best place for AI to help me out, right? I often run into a blank page problem. I get given a spec to track something, to understand something. And I want to know, okay, well, what could this data structure look like? Now I'm giving the AI all the detail it needs. It knows about all of my existing data structures. It knows about my existing data products. It knows what the ecosystem I'm working in already looks like. So when I say go and build that e-commerce tracking event, it can go and research and look for anything that's a previous match. It can look for out-of-the-box systems that might already be there. It can check if anyone else in the estate matches this. If it doesn't, it'll go and create a new one. It'll follow the conventions already set out. And actually, the more data you give it on this context, the better it actually produces having mic issues. No, there we go. And the MCP server gives it a lot of that extra detail. Once I've gone through that ideation phase, that publishing phase, I can push it for review. There are GitOps flows that we support as well. And I can then pass the properly defined tracking to my developer teams to do the implementation. So they're using CodeGen with the exact that I've supplied, and they're not going to have any issues there, obviously, because it's Snowplow and it all works perfectly all the time. They will go and implement that tracking, and they will be using deterministic tooling for that. So when that code goes out of review, it's not LLM hallucinated drivel like we saw from Claude and Gemini there, where it's kind of making things up on the fly. It'll be tracking exactly what I've defined reliably. And I can continue this loop. If I need to iterate on that data structure, I start again with the AI, with my MCP. I push those definitions out, they get reviewed, and I can code gen and evolve those data structures as well. So it's a constant loop there, where I'm not, again, depending on LLMs for the implementation. I'm depending on it to help me as a design partner, right? And that's what I want to use the LLM for. I want to use it as a design partner. I don't want to use it to write code all the time. That can be very useful. I think the main reason I don't like to use LLMs as that code gen for data in particular is that data leaves your system, right? When you think about code gen for functions, that's staying within your app, right? You've got an interface, you're going to use it, you're going to get a result. It'll probably work. It's constrained within that ecosystem. Data's going to leave. It's going to live potentially forever or until the cloud stops working. So you want to make sure that what's leaving your app that other teams are going to consume is perfect. It has to be perfect. It has to be high quality. So I'm going to do a couple of screenshots of a demo. I don't trust LLMs to do anything for a live demo. I'm not going to tempt the demo gods that much. If anyone is interested in seeing this in practice, please come and come have a chat with me at the booth after. I'd be more than happy to run you through this. But the same flow as before, right? That contrived example. So let's use the toolchain I've just talked about and run through that process. So I've asked Claude Code, in this case, with my MCP server to go and create that exact same schema. I've said, right, I need a product schema with product ID, product name, category, and price. And there's a few details already that are changing here. In the other examples, it was strings and numbers. I've now got not only that, but I've got constraints. It's also matched the casing of the rest of my system. It's using camel case rather than snake case. And I now know that my price can be 0 to $1 million. That's a lot. I've got categories, I've got product names, I've got product ID. Every field now has limitations, clear understanding of the schema of these different columns, right? I didn't have any of that before. I was just tracking an arbitrary string of whatever length could have gone through. I'm now also able to iterate on that and say, well, I want to price, I want to add description. I can then go and iterate on that and it'll keep following the same design. If I wanted to go further with this, I could say, well, category to be an enum, and it'll help me build this in. It'll help me validate and build a concrete schema that I can work. So I can iterate on this, I can validate this, I can push this out, I can then code gen it. And that's exactly what ends up happening. So I end up having my schemas here. I've added a few extras, so I now have my product page viewed, my add to cart. I can now go to my code gen tool, and as a mainly backend developer, I'm going to use Golang here, and I can go and generate this structure straight into my code base to be leveraged by developers. So if they now need to they now need to capture this information, they've got a schema to follow. They've got exact definition of what needs to be filled. We're not going to worry about column names. We're not going to worry about constraints. These are all going to be enforced by the generated code and then the pipeline downstream. So we've taken hopefully the effort out of doing a schema on write system, which again, we firmly believe is the right way to track data, by leveraging AI to kind of speed up this loop, right? So we're still using AI where hopefully it makes sense without causing hopefully a lot of data trust and quality issues downstream. So I think here, what we want to use MCP and AI for is kind of the bulk of what I've been hopefully trying to get across. We need to leverage AI where it makes the most sense. It's a really big hammer. And anyone in this room that's used ChatGPT or Claude or Gemini knows that you can literally ask it anything and it'll give you some result. And it'll be very confident in that result. It'll say, yes, this is the right solution. It's a big hammer. Not every problem should be treated like an AI nail. And beyond that, the tenets for high quality and trustworthy data haven't changed. We now have AI. We can move faster, but it doesn't mean that we should throw out all the rules that govern high quality data. So you want to shift data quality left, you have to be defining schemas up front. You can't leave it to the warehouse or in stream to kind of figure this out. So how do we do that? We have to leverage the tools to help us move faster, obviously. Every exec team is going to demand that from you, but how can you do that without breaking everything downstream? I think that's kind of what you can use AI for. And garbage in is still going to be garbage out. So if you're not doing this, if you're not taking care of your data pipeline and validating everything up front, shifting left as far as possible, you're going to create a lot of garbage. You can create garbage at an unprecedented rate, right? You can generate all this tracking and it'll work. It'll look sort of correct, but it's still going to be garbage. And if you want to use low quality data, well, you can't leverage it for a lot of very interesting use cases that I'm sure a lot of us are being tasked with figuring out. You want to do real-time personalization where all of your schema definitions don't match? That's going to be really, really difficult. How are you going to build any sort of system that depends on data without high trust and quality in that system? So I guess the key takeaways that I wanted to get wrong, leverage AI for fast design loops. It's amazing as a design partner, and I love using Claude for a lot of this design work. But we can't use it for everything, and we shouldn't use it for everything. We need to find the right place to use AI to get the advantages from it without breaking all of the trust and quality downstream. And beyond all, context for AI is crucial. If you're not using MCP already with all of your AI agents, you're missing out on an amazing shift. So yeah, anyway, these were the main. Through that much faster than I anticipated, so I've got plenty of time for questions if anyone has any. Yeah, that's about all I had. So if you'd like a demo later on, do come and visit us at booth P78. We're over near the streaming area. Yeah, let's continue the conversation. Thank you. Yeah. Did anyone have any questions? Oh, yes, we have a question here. Thank God. Bring the mic around.
Yeah, hello, thank you for the section. So if you go back to the slide with the graph where you got like developer and then yeah, this one, and then you mentioned that for this one you can make sure that you got like the high quality data and then you can check everything.
Sorry, could you say that again?
So like for this one, when you mentioned is that you're not getting the hallucination from like the AI agent, so you got the high quality data and things that you can actually check. Can you clarify a bit more on that, like how you make sure that it's like,
we're not necessarily. So I think it was how to avoid like AI hallucinations in this phase. Did I get that right? Sorry.
So like for like avoiding the AI hallucination in this.
Yeah, sure. So you're not necessarily avoiding the AI hallucinations. You're centralizing the impact that AI can have on the system. So by using AI at the ideation and design phase and then publishing that into a central schema registry, you've got a very controlled audit trail of how you're producing that data structure. So you're using it for design, you're using it to help you build that system out, but then you're centralizing and dispersing it with deterministic tooling. So rather than saying to your 5 different dev teams, go and implement this style of tracking, you're saying, I've developed this tracking, I own this tracking, I own this definition, now go and implement it. And there's no hallucination in that process. So when you actually go to implement the code, it should be robust. Obviously, if you're not checking your work, you can still use terrible things. You know, I think this is about limiting the scope and trying to control a little bit better where you use AI to hopefully govern and control that much better than you otherwise would. Very sorry.
So it's like you giving out the like more precise context for the AI as much as possible.
Exactly. You're giving it really precise context on how you're developing the data structure, what already exists in your ecosystem, so that you don't end up with varying implementations across the board. Anyone else? Oh, got another one over there.
Thanks. Hi, Boris here. That's enough. I wanted to ask you whether you consider using synthetic data as a way of enhancing your process of generating those schemas for additional validation, because synthetic data can help you see.
Sorry, I'm really struggling to hear. Could you speak?
Yeah. Yeah. Sorry.
Big. Thank you.
Not the inner voice. So I was wondering whether you tried introducing the synthetic data into your process of generating schemas for an additional validation and for ideation in general.
You definitely can, yeah. So I think this is all about feeding context into the system. So if you have a lot of existing data and synthetic data, or you want to even do something like schema inference with AI, you definitely can. It's about providing the details in. So with MCP, again, you could load that all into a local file system, and you can say, right, read through this first, then help me produce a schema that encapsulates all of these details. 100%, yeah. It's a bit of a cheat code to doing the hard work. In context, I used to do a lot of data structure definition by hand. So we've always been schema on write, right? So 10 years ago, imagine creating giant JSON schemas, 200 lines long with lots of nested validation. It's terrible. It's the worst job imaginable trying to do that up front. And anyone that's worked at Snowplow would have gone through this at some point. There's a few of us in the crowd, but this takes a lot of that effort and work out, right? And we firmly believe that schema on write, doing that data quality left, is the right choice. It's hard though, and it takes a lot of time and effort. So this toolchain is about figuring out how can we do this quickly and easily, and kind of take some of the pain and effort out of it, so you get the high quality data. But yeah, definitely.
Thank you very much.
No worries. Anyone else? Oh, got one more. It'll get there. Cheers, mate.
Hi, thanks for the talk. How far into kind of helping the design do you see this going? So, for example, I can see how it suggests to create new events that follow a consistent syntax format. Do you think it can help people suggest to reuse existing events in a registry, or even point out where a very similar event has just been created, you should perhaps create a common event, that kind of thing? Like,
it definitely does, which I've been testing it quite a lot, obviously in the follow-up to this event, to make sure I had all my details right. But on a large existing estate of schemas, it will very quickly start to pick out common matches. This is obviously also in, the prompt that you provide, right? You want it to search for those existing matches. It does very well at finding existing implementations and helping suggest, either an augmentation to an existing event rather than a whole new event, as well as, following your style guide, right? So in Snowplow, you can also have events and entities and that kind of distinguishing feature. I know you're customers, so you're familiar with some of this. So it'll figure out kind of how you've developed your tracking already, and it can see what those structures look like through the lens of a data product. So we'll start to see how you've combined, how you're putting your data together, and it can suggest very similar patterns and styles to keep you in that ecosystem. So yeah, it works beautifully for that.
cool, thanks.
Okay, I think we might be wrapped. Perfect. Thank you so much, everyone, for coming along. Again, if you'd like any more details, do visit me at the booth. Yeah, thanks again for coming along. Have a great rest of the day. Cheers.